Alright guys, so this is AKS 14. This has synthetic and long division. And you can do this problem actually two different ways. I'm going to show you both ways just so you can get a feel for how they connect. So for instance, if I'm going to do this during doing long division, I'm going to write the divisor on the outside. So the divisor is whatever you're dividing by. Okay? And I'm going to write this lower because that's not going to make sense. Alright, so divisor on the outside. Then everything inside here, I'm going to write it on the inside. And I'm going to put it in descending exponent order. And I got to make sure that I write out all of my exponents. So what I mean by that is you see how it has 3, 2, 1, and then no exponent right here. All right. So what I'm going to do first is I'm going to say 6x to the third power. If I divide it by x, what am I going to get? I'm going to get 6x squared, right? So then I'm going to take 6x squared, multiply it by x. That's going to give me 6x to the third power. I'm also going to multiply it by this negative 2. So 6x squared times negative 2 is going to give us negative 12x squared. I'm going to change the sign and draw my line. So really, I'm just going to subtract. So these will cancel out. Negative 19x squared minus negative 12x squared. That's going to make it a positive 12. So that's going to give me negative 7x squared. And I'm going to bring down this guy. All right, so now I'm going to take negative 7x squared and divide it by x. Okay, so negative 7x squared divided by x is going to give me negative 7x. Negative 7x times x is going to give me negative 7x squared. Negative 7x times negative 2 is going to give me a positive 14x. I'm going to change the sign, draw my line. Okay, so negative 7 minus negative 7 is going to give me 0. 16 minus 14 is going to give me 2x. And I'm going to bring this guy down. And I'm going to repeat this process until I run out of numbers. All right, so 2x divided by x is going to give me a positive 2. 2 times x is going to give me 2x. 2 times negative 2 is going to give me negative 4. I'm going to change the sign and draw my line. These will cancel out, and so will these. So this guy has a remainder of 0. But let's say it did have a remainder. Whatever this number is, I'm going to write it up here, and then I would put it over the divisor, which is x minus 2. But since we don't have a remainder, we're just going to leave that guy off. Okay? So this would be my final answer up here at the top. Okay? I can do this with synthetic division. It's a lot faster. So really quickly, I'm going to change the sign of my divisor, which is going to make that positive 2. Put it in the little box. I'm going to list out all my coefficients in descending exponent order. Bring down that first term. Multiply those two. Add those together. Multiply. Add. Multiply. Add. And then I'm going to write one less exponent than my leading term. So that's going to be x squared minus 7x plus 2. That's exactly what I got on this other one, and it took me like 2 seconds to do. So the only reason why I can do this synthetic division is because I've got this exponent. This leading term does not have a coefficient bigger than 1, and it doesn't have an exponent bigger than 1. So I can use synthetic division on this guy. All right, so on this one, this is AKS 11, finding all zeros, roots, or factors. So this is to the third power, and it is in standard form. So there's a couple different ways we can do this. We can either graph this one, and then basically be able to tell what the x-intercepts are, or we can factor this one by grouping. Okay, so how I'm going to factor this by grouping is by drawing parentheses around the first 2 terms and the last 2 terms. And I'm going to take the greatest common factor of this. So what does x cubed and negative x squared have in common? Well, they both have an x squared in common. Well, what's x cubed divided by x squared? X. What is negative x squared divided by x squared equal? negative 1. All right, cool. I'm going to repeat that same process over here. So what does 9x and negative 9 have in common? Well, they have a 9 in common. Well, what's 9x divided by 9? X. Negative 9 divided by 9, that's going to give me negative 1. All right, do you notice how this right here is the same as this? Okay, well, that's supposed to happen, okay? Because remember, we are factoring by grouping, so we're going to have one extra parentheses that we really don't need. So we're going to cancel this one out. We're not going to need this guy. We're going to bring down this parentheses. You see all this remainder stuff out here? We're going to squish it together and put it in a parentheses of its own. The reason why I wrote a plus sign is because this is a positive 9. Okay? So now what I'm going to do is I'm going to set both of these parentheses equal to 0, and I'm going to solve. So I'm going to take x minus 1. I'm going to take x minus 1, set it equal to 0, and I'm going to solve. So that's going to give me x equals 1. I'm going to take x squared plus 9, set it equal to 0, and I'm going to solve. So that means I'm going to subtract 9 from both sides. And now I'm going to take the square root. Okay? When I take the square root, I'm going to get 3, positive and negative 3. Remember, I'm going to have that I term because there's a negative 9, right? If we have a negative underneath the radical, that means that we're going to have an imaginary term. So what are the zeros, roots, or factors? They are x equals 1, positive 3i, and negative 3i. So this guy has 3. And the reason why it has 3 is if we look at the leading term, exponent, that's also a 3. Okay? And that tells us that there's going to be 3 roots. Cool. All right. This next one. This one always gives y'all a lot of trouble. It's finding the zeros of the polynomial function from the graph and then create an equation based on the graph. Okay, this is talking about multiplicity. So first thing I'm going to notice is that it touches at x equals negative 3, touches at x equals negative 1, and it touches at x equals 4. So I've got x equals negative 3, x equals negative 1, and x equals 4. Okay, and hopefully your teacher talked about bounce, wiggle, and cross. Okay, if you cross, that means you cross the x-axis. You're going to have a multiplicity of 1. If you bounce, you're going to have a multiplicity of 2. And if you wiggle, you're going to have a multiplicity of 3. So what I mean by that is, do you see this guy right here? Okay, he goes down and then he goes back up. That's called a bounce. Okay, so at x equals negative 3, we're going to have a bounce. So that means that I can write this for my equation as x plus 3. And I'm going to raise it to the second power. And the reason why I'm writing it x plus 3 is if I was going to try to set this equal to 0 right here, I would add 3 to both sides. And that would give me x plus 3 equals to 0, right? Okay. So now let's look at where it crosses at x equals negative 1. You see how it goes straight across? Well, that's a cross, right? So when I write this, I'm going to have, I should have color coordinated this, I'm sorry. All right, so I'm going to have x plus 1, and I'm going to raise that to the first power, okay? All right, so my last part, you see how it goes right across, right across here. And it kind of like goes in, touches it, and then goes back up. That's what we call a wiggle, okay? So when I write this, I'm going to get x minus 4. We're going to raise that to the third power, okay? All right, so we're going to check and make sure that our graph is correct. And the easiest way to do this is to put it in your graphing calculator. You will, on your final exam, have a graphing tool on your computer. There's a TI-84. Make sure that you use it. If you've never used a TI-84, you can go onto Google and literally learn how to use it off of there. Or if you have questions, just come by my classroom. I'll help you out there. I'm hoping to do a tutorial on that probably soon, just because it is a really good tool for you to use. So if I type this into Desmos, and then we've got x plus 1. Sorry that you're watching me just type this in, but here we are. Alright, so it's looking like a whole hot mess. I don't really think you can see much of anything, so I'm going to make this big screen. Okay, so we've got this cross at, or this bounce at x equals -3. We've got this right here at -1, and then we've got this at 4. I mean, that looks roughly like the graph. However, I think we're missing a leading coefficient somewhere in here. Actually, no, if we zoom out far enough, do you see how this right here goes at, like, y is like -170? So if we actually go back to our graph and we zoom out or zoom in to where x equals 170, it goes a little bit farther down. So that means that we're going to have to add some type of number to it so that I'll make it a little bit easier to see. So at this point, I would probably take my biggest guess, because obviously you're going to have multiple choice answers for this one. So I would probably try to get as close as possible. Or really, guys, I would just plug it into your graphing calculator and go from there. But your equation can be written out like this, or it could be written out in standard form. And really, you would just take this and you would multiply it all the way out. So there's one aspect of this I'm probably forgetting, and I'll probably come back and make an edit on this one. But that's actually how you find the zeros of the polynomial. So there you go.